Good morning, everyone. Today, I'm going to teach you basic integration formulas, general integration formulas, and use substitution to techniques of the integration by parts. First of all, let's read our learning objectives. To be able to understand the concept of integration, to be able to solve simple problems using the integration formulas. Next, here are the basic integration formulas. As you can remember, we first learned how to do derivatives, and integration is just the reverse of derivatives. So as you can remember, so the integral of 0 d over dx, the integral of 0 dx is equals to c. Integral of 1 or any number is equals to x. And if it's 2 dx, the integral of 2 dx is equals to 2x plus c. And that formula is represent and that problem is represented by the a dx is equals to ax plus c. And another formula is ax dx. As a is a constant, we can just put it outside the integral symbol so that can be easier to solve. So a times the integral of x dx. And the integral of x is x squared divided by 2 plus c. Then you just transpose a and you just copy a. The formula for that is a is the integral of ax raised to n dx is equals to a times the integral of x raised to n dx, which is equals to a times x raised to n plus 1 divided by n plus 1 plus c. And that's basic integration formulas. You can solve most simple problems using these formulas. Now, we're going to try to answer some problems. Here we can see basic integration formulas. And let's try to solve this. And so it's integral of 4x raised to 4. So it's going to it's equals to 4 integral of x is to 4 dx, which is equals to 4x raised to 5 divided by 5. Let's undo that. Sorry, as I am still trying to x to 5 divided by 5 plus c. And we solve this using this formula. Then let's go to the next problem. Let's clear this first out. And here we have another problem, which is the integral of dx divided by 4 raised to, divided by 4 x raised to 4. So first we need to take out the constant, which is 1/4, and we need to transpose x raised to 4 upwards, so it's going to be x raised to negative 4 over dx. Now we can solve. So 1/4. Okay, so this is negative 4, and we can see here we need to add 1 to the exponent. So it's going to be x negative 3 divided by negative 3 plus c. Oh no, wait. Okay, plus, wait. Sorry for interrupting that. So it's going to be plus c, which is going to be equals to this multiply the denominator, so it's going to be negative 1 into negative 1 divided by 12x into x raised to 3 plus c. And that's how you solve that. Now we can move to the next problem. First, let's clear all of this. Here is number 3. First, in order to solve this problem, we need to simplify it. So it's equals to integral of x squared plus 8x plus 16. Oh no, wait. Plus 16 over dx. Now we can solve. In order to solve this, we need to use the sum rule of integration. So it's going to be x raised to 3 divided by 3 plus 8x raised to 2 divided by 2 plus 16x plus c. Now simplify. 1/3 x raised to 3 plus 4x raised to 2 plus 16x plus c. Okay, that's how we solve that. Now we move to the next problem. First, I need to clear this, clear all drawings. And another topic we have is general integration. For, is the general integration formulas and use substitution. First, we have logarithmic. The integral of a divided by x dx is over d by dx is equals to a ln x plus c. As we can remember that x that x is that 1 over x, the integral of that is equals to ln x. And then we have the exponential functions, which is the integral of vx is equals to v raised to bx divided by b plus c. We also remember that the exponential okay. So now we go to use substitution. Here we have the integral of u raised to n over du is equals to u n plus 1 divided by n plus 1 is plus c. This is just another version of the previous formula we had. But this time we need to use substitution in order to use this formula. The same is also with the du over u, which is ln u plus c. The same with the exponential function, and the same with the and now we go to the trigonometric functions. These formulas are the formulas you need in order to get the integrals of trigonometric functions. This is just exactly the reverse of derivatives, as the derivative of negative cos x is equals to sine x, and the derivative of sine x is equals to cos x. Same with tan x is equals the derivative of tan x is equals to second raised to second squared x, and then derivative of negative cotangent x is equals to cosecant squared x. And the same can be said for the rest of these formulas. Now, using these formulas, we will answer some problems. So let's go to the next page. Here we can see an example. Oh, wait. I seem to, oh, wait. Here we are now. So first I need to annotate this. So we can solve this now. This is equals to, oh no, do this first. It's equals to, no, we need to use u substitution to solve this. So u is equals to x plus 4 and du is equals to dx. So this is going to be wait. Oh, I forgot. We need to first simplify this. So this is going to be mm, so as we can see, we have here plus 4. We can use this form. We can do this. X plus 4 minus 4 divided by x plus 4 over dx. And we can now simplify this. This is going to be as x plus 4 divided by x plus 4 is equals to 1. And the remaining is negative 4 divided by x plus 4. X plus 4 over dx. Now we can solve this. So negative 4 integral of 1 over u, as we as already discussed, that u is equals to x plus 4 over du. So we also substitution over du, not x. So as we already substituted, du is equals to dx. So it's going to equals, this is equals to wait, I forgot. This is not, we didn't take out this one, but we need to find the derivative of 1. So plus, so it's equals to x minus 4, as we already take out the 4. So 1 divided by u is ln u, and ln u is x plus 4. So x plus 4. And that's correct. And plus c. Now, and that's how we get the answer. I forgot that we still need to find the integral of 1. Integral of 1 is equals to x. Rian, I'm recording. Don't disturb me. Okay, I'm back. Sorry for that disturbance. As it was something urgent. So let's get back to this. So uh, as we already answered this, let's first clear this. Okay. And let's okay. Here we have another form. Here we have another problem. And this is solved using the exponential function formula. So u is equals to 4x d du is equals to du is equals to 4 over dx. Now we we replace these values with the problem, so it's going to be 1/4 the and times the integral of a raised to u du, and this can be simple and this can be answered now. So 1 divided by 4 times u plus c. Now we just need to replace the u. So 1 for e raised to 4 for x plus c. Now we can go to the next problem. Okay, here we have another problem, and so we solve this using the u substitution, and u is equals to ln x, as the derivative of ln x is 1 divided by x, and and the value of dx here is just 1, and 1 divided by x equals to is the integral, is the derivative of ln x. So the du is equals to 1 over x over dx. So this is just going to be integral of du over x, as due to this being the due to the derivative of ln x being 1 over x, we cancel this out. So only thing remained is ln x, which is equals to u. Oh, wait, which is equals to u, not x, which is equals to u. Now this we can solve as ln u plus c. Now this can be, now we just need to insert the values. So ln x plus c, and that's now solved. Now we need to let's clear this first out, and now we have another problem. Cos x squared. Here we need to use our previous knowledge of trigonometric identities in order to solve this. So as I remember, cos cos raised cos squared x is equals to 1 plus sine squared x. Oh, I forgot. This is this is this this is my negative. So cos raised to 2x is equals to 1 minus sine x sine raised to 2x over dx. And we can simplify this further as sine squared x is equals to if I remember correct, it's 1 minus cos 2x divided by 2. So it's going to be 1 minus 1 minus cos 2x divided by 2 dx. So, and now, and we can just simplify this. So it's going to be integral of 1 half as this is negative. So this is also negative. It will become positive. So plus cos 2x divided by 2 dx. Now we can solve this. So it's equals to 1 half x plus mm, plus 1 half 1 half and sine 1 half 1 half times sine 2x plus divided by 2 plus c is equals to 1 x plus 1 4 sine 2x plus c. Okay, now that's solved. Clear this first. Here, as we can recall, the derivative of ue is u times the derivative of v plus v times the derivative of du. In integration, the integral of u dv is equals to u times v plus minus the integral of v times du. And using this formula, we can solve the next few problems. Here we have an example. Wait, I got some problem on my end. Wait. Wait. Okay, now we can start. As we have seen a formula, we can first start by finding the u. U is equals to x. Du is equals to 1. And v and dv is equals to cos x. And v is equals to sin x. Now, using this formula, we can write this now. So it's equals to u times v. So x sin x minus integral of sin x and of sin x dx. Now we can now solve this thus as the integral of sin x is equals to negative cos x is equals to sin x plus, as we have just said, sin x is equals to negative cos x, and we have a negative here, so it will become positive. So cos x plus c. Let's move to the next problem. Okay. Here, instead of just repeating this, just repeating the integration by parts formula for for many times, as it will take you very long solvings to solve this, we can use what our teacher called diff method. First, we first need to get the diff and the integrals. And the diff of x raised to 4 is equals to 4x raised to 3. And the differential of this is going to be 12x raised to 2. And then 24x and then 24. And we have here all of this is just e raised to x, as the integral of e raised to x is always equals to e raised to x. Now we can write this. Now, in order to write the answer, we first need to connect all of this. Always skip the upper rightmost. So it's going to be x raised to 4 ex. And I forgot that we need to add this. So this will decide if it's going to be a negative or a positive. So, and the next is negative 4x raised to 3 times e raised to x. And the next one is 12x raised to 2 of e raised to x, and plus, I know, forgot it's minus, so minus 12, 20, 24x e raised to x plus 24. And that's how you solve long problems using the integration by parts of using diff method. And now that's solved. Let's clear this and let's go to the next problem. Okay, this is the last problem. So we need to okay, you can now start. And take take note in getting the integration by parts. U is not always the first value as the derivative of ex of e raised to x is always to e raised to x, and that's just going to repeat forever if that's the u. So the u in this case is cos x, and the du of this is negative sine x, and dv is equals to e raised to x, v is equals to e raised to x. Okay, using the diff method, you can also get this. So cos x then negative sin x. This is wrong, as the derivative, as this can also go as this method can also go further forever, as the derivatives of of trigonometric functions just repeats on forever. So just use the normal formula in this case. So that's going to be is equals to uv, so cos x e raised to x minus integral of v du. So e x and du is negative sine x dx. Now we can solve it. We need to solve this again. So it's going to be u is equals to negative sine x dx du is equals to cos x, no, negative cos x, and v is going to be e x dv, I mean, and v is also equals to ex. This is going to be cos x is to ex minus u and v, so negative, so this plus sine so is equals to sine x ex minus ex cos dx, and this is equals to the original problem, so this will be cancelled out and it will become 2 here, 2 here, so it's going to divide 2. So this is now the answer. Plus C. Thank you for watching and see you next time.